Good morning. This is your stats sensei, Mr. Spensei, and this is a warm up for confidence intervals. So, a credit card company wondered whether giving frequent flyer miles for every purchase would increase card usage, which has a current mean of 2,500. They gave free miles to a simple random sample of 36 card customers. So, our sample size is 36 and found the sample mean to be 2542. So, our X bar is 2,542. That means this current mean is talking about our population. So our population mean, or mu, is 2,500, or we believe it to be. Assume the population standard deviation is 109. All right, it's very important to have the population standard deviation so that we can work with the normal. They didn't tell us our distribution was normal, but our sample size is greater than, our sample size is 36, which is greater than 30. So it's going to be normal by central limit theorem. So what are the z-scores associated with the middle 90%? All right, so they're asking for the z-scores and they gave a percentage. So this tells me that we're going to be working with an inverse norm. And once again, this center section is 0.90. We're looking for a lower and upper. So inverse norm. And the area that we're looking for is 0.90. Because we're working with a z-score, our mean will be 0 and our standard deviation will be 1. And we're looking for the center values. So going to the calculator, second vars, inverse norm, area 0.90, mean is 0, standard deviation 1, and we want to be centered. And we get a negative 1.66, negative 1.6448, and of course a positive of the same thing. So 1.6448 negative, that's my lower, and my upper is 1.6448. And the reason they are opposite is because we are symmetric and centered about 0. So plug into the equation x bar plus or minus z star, standard deviation divided by the square root of n, and calculate a 90% confidence interval. Well, we said x bar is 2,542. So we have 2,542 plus or minus our z star we just calculated. So that's going to be 1.6448. Our standard deviation of the population is 109. And our sample size is 36. All right, so we're going to go to z interval on the calculator. Stat, test, drop down to z interval. We want stats to be highlighted. Our standard deviation is 109. Our X bar is 2542. That's the sample mean. Our sample size was 36, and we want a confidence level of 0.90. And we end up getting 2,512 and 12,571. So $2,512.1 to somewhere between $2,571.90. So we're 90% sure that with the frequent flyer miles, this is our new our new center. All right. What are the z-scores associated with the middle 95%? Well, once again, we're going to, since they're asking for a z-score and they give us a percent, we're going to be going to the inverse norm. So this is going to be, this area right here will be 0.95. And we're looking for a lower and an upper, and it's inverse norm 0.95, mean is 0, standard deviation of 1. And remember, the reason it's a mean of 0 and a standard deviation of 1 is because we are working with a z-score, and all z-scores are that way. So this is the center, or all z-scores for the normal are. So second vars, inverse norm, 0.95, mean of 0, standard deviation 1, and centered, gives us a 1.9599. And a 1.9599. So this is my lower, and this is my upper. Plug into the equation x bar plus or minus z star and calculate a 95% confidence interval. All right, so once again, our x bar, we had that earlier, was 2542. That didn't change. Plus or minus our z star. We're going to use the positive because of the plus or minus, so it doesn't really matter. We have plus and minus covered. So 1.9599. And then we need our standard deviation and our sample size. Our standard deviation is still the 109 that we had before. And our sample size is the same as we had before, which was 36. All right, so stat, test, z interval. And the only thing I need to change is my confidence level to 0.95. And now we're at 2506 and 2577. So 2506.4 and 2577.6. So here's my lower and there's my upper. As we continue to move on, what are the z-scores associated with the middle 99%? Once again, we're looking for z-scores. And this area is going to be 0.99, and this is my lower, and this is my upper. So it's going to be an inverse norm. And my area is 0.99. My mean, because this is a z-score, is still 0. And my standard deviation of 1, and we need to be centered. Second vars, inverse norm. Change my area to 0.99, 0, 1, make sure we're centered. And we get 2.5758, negative 2.5758, and a positive 2.5758. Those are my upper and lower and upper z-scores. And it says plug into the equation. All right, so we still have the same 2542 for the x bar. So 2,542 plus or minus. And we always like to use the positive. So plus or minus 2.5758. Our standard deviation is still the 109 that we had before. And we have the square root of 36. So, stat test number 7, which is the interval, 109, 2542, and change our confidence level to 99. And we end up getting 2495.2 and 2588.8. So 2,495.2 and 2,588.8. All right, number 7. What do you notice about the interval as the confidence level or the percentage increases? Well, as the percentage increases, we were at 90% and our z-score was 1.644. Then it increased to 1.95. Then it increased to 2.57 when we went to 99%. So every time we increased our confidence level, our z-score got larger, which means we were multiplying by a bigger number. And look, our highest value was for the 164, for the 90% was 2571. But when we went to 95, it went up $6 to 77. And then when we went up to 99, it went up even farther. It went from 77 to 88, so $11. So what we noticed is it got wider. All right. It got wider because we had more standard deviations. Our z-score increased. So what did we notice? As we increased the confidence level, the z-score increased, which made the interval wider. All right, thanks for watching, and I hope to see you on the next one.